So here we look at one question, number 12. It's on page 52. So the question says, each stroke of a vacuum pump extracts 5% of the air in a 50 cubic meter tank. How much air is removed after 50 strokes? So if we reverse the thinking, so we look at after the first stroke means you taking 5% of the air out, so there will be 50%, 50 cubic meter multiply 95% left. Okay, basically you have 95% of the air left in the tank, so that's the air left. And then after the second stroke, basically you have another 95 of this left, so you multiply 95% on here, and then you got 95% squared left. And if you follow this pattern, you can see after 50 strokes, so you should have that much left. So the exponent 50 here exactly same as the number of strokes. Okay, see, we don't need to do anything like series, geometric series, right? So this is actually just a sequence. You can tell this is a sequence, geometric sequence. So this is the last term. So we can just calculate this would be how much air left in the tank. And then the question asking for how much air being extracted. So we just take the original 50 cubic meter, subtract the one left. So we got his answer. Okay, so that's the question. Only use a geometric sequence finding the last term. Okay. And there's alternate way to do this. Things you already know. After each pump, each stroke, how much air left. So we can easily figure out the first stroke taking 5% out. So we 50 multiply 5%. So that's air being extracted out at the first stroke. And then the second stroke is another 5% of the air left. The air left is we actually figured out here. So after the first stroke, we have that much air left. So that's why on the second stroke, 5% multiply this, that's the air being extracted out. And follow the pattern, the third time should be that much left, multiply another 5%. So we got this. And then follow the pattern, you can tell at the 50th stroke, we must extracted that much air out. Okay, so then we just add up all these terms. So obviously it's a geometric series. So the term 1 is 50 multiply 5% right here, and R is 95%. If you use any term divided by the previous term, right? So then we have 50 terms, right? The first stroke until the fifth stroke, and then just apply this formula, right? So the T1, 1 minus R, 50 divided by 1 minus R. So we got the same answer. Okay. Okay, then we come here. This is just a question students might have frequently. Sometimes the students ask if we need to square, because this formula you need to have a power operation on the r, right? Now, what if the r is negative? If the r is negative, so you have to power the negative base. So if you do this way, for example, if r is negative 1 over 3, you have to do this way, because you're going to square or cube or whatever the exponent is on the negative r, right? So the r is negative. And then if you do this way, you actually put the power on the 1 over 3. And then outside we have negative. So basically kind of negative 1 multiply this. Okay, so as a result, you can see they're different. So this negative 1, negative just by itself stay there. So when you do the square of 1 over 3, so you multiply twice. But if you include the negative sign, so you end up getting this. So this is positive, this is negative. So they're different. This is another mistake students might make. So if you look at this part, that's not the same at all. You cannot cancel this 2, right? Now, because 2 to the power of n minus 1 is 2 multiply 2 until n minus 1 times, right? So if you see this, you can see you can only cancel one of the 2. That means you got a n minus 2 2 left, right? You have that many 2's. Okay. Okay, so for the homework, you should study for the checkpoint 2 for a quiz next class. So I'll make it clear, the quiz will be next class. Okay, now I'll go over some of the questions. Okay, first I'm gonna go over question number 2 on the checkpoints. So that's on page 55, number 2. So it's given a geometric sequence 2, -6, 18, -54, and asked you to write a rule to determine the nth term. Find a rule to determine nth term. If you remember on the checkpoint 1, we have very similar question. Of course, we were talking about arithmetic sequence. Now here, this is a geometric sequence. It's a different story. But we also know the basic information. T1 equals 2 here. Common ratio are -6 divided by 2, -3. And then what's the Tn, right? Tn, the general formula is T1 r n minus 1. Now you can't stop here because we already know the T1 and the r. So we plug in -3 and -1. Okay, now basically that's it. Now if you want to simplify, you can do something, but I don't think you need to do that. And then the second question, B, this is A, right? And the B is asking to use the rule to determine the 10th term. Now I don't want to go over that. It should be easy. Just plug in the n equals 10 into this, and it simply calculates, right? Okay, next question I like to look at number 5. Number 5 on page 57. Okay, So it given data, I'm actually gonna go over the B. So the general instruction is they give you a couple uh, data and then ask you to determine something. For the B, you're given the geometric series. So you got the series, metric series is given as 3125 plus 625 plus 125 plus 1 over 25, and then determine n. Okay, we have the series and how many terms are there, right? That's basically the question asking for. Okay, so we need to determine the basic information. So for this geometric series, obviously we know the T1 is 3125. The common ratio is not as obvious as the previous one, so we use 125 divided by 625, and that equals 1 over 5. Okay, based on the formula Tn, actually we also know the Tn equals 1 over 25. So based on the formula Tn equals T1 multiply n minus 1. So we plug in everything we know. We should have left the n for the only variable. We plug in, so 1 over 25 equals T1 is 3125, and multiply the r is 1 over 5, and this is n minus 1. Okay, now here again, because you haven't learned the logarithm, so this kind of question you have to do the guess and a check. Okay. Now of course this question is pretty simple. If you follow the pattern, just multiply 1 over 5 all the way, so you can see the next term or the fourth term should be 25, and then 5, and then 1, and 1 over 5. So it's kind of like about 8, and probably equals 8. So let's try. We try n equals 8, and then calculate 3125, 1 over 5, 8 minus 1 equals 7. Let's calculate this. Okay, that's actually, now if you calculate it, you're probably at 0.04 on your calculator. And that's exactly equals 1 over 25. Here you go. So then the n equals 8 is the solution. So we can see the n. So the n equals 8 is the answer. Right? Okay.